Hi, welcome to our Algebra 1 videos on solving inequalities, graphing inequalities. When you're solving an inequality, it's just like solving an equation, but there is one key difference. When I have, or I guess two key differences. One is, when I'm solving an inequality, I have an infinite number of solutions. Assuming it is a regular inequality, not a compound inequality. I also have to worry about if I have a negative with the variable. So if I have a negative with the variable, as I do here, then what I'll have to think about is switching that inequality symbol. So in this case, we would solve it just like a normal equation. I could say negative 4x is greater than 12. But here's what happens. We will need to divide by a negative, and when I divide or multiply by a negative, or maybe more concisely, if I have a negative being multiplied by the variable, if I have a negative variable term, after I combine all my variables, then I'm going to have to switch this inequality sign from less than to greater than, or from greater than to less than. So let's see what would happen if I forgot. Here, I would get x is greater than negative 3. Now, I know that's wrong, and I know that this should be switched to be less than. But let's see what would happen if I were to forget and check my work. So here's negative 3. If I were to check my work, greater than negative 3 would be over here. So let's use an easy number like 0. If I were to substitute in 0 for x, negative 4 times 0 plus 11 is greater than 23. This would say, that'd be 0, that would be 11 is greater than 23. But I know that's not true. So, just as a reminder, I need to switch that inequality symbol because I multiplied or divided by a negative. When I switch that inequality symbol, it works. So this is correct. That works. It's true. Here's my final answer. And when I shade this, I'll need to make an open circle because this inequality is just less than. It is not less than or equal to. Because there is no bar underneath there, no equal to symbol, I have an open circle. And then this inequality points to the left. So my arrow will point to the left, and that will give me numbers that are less than negative 3. All of these numbers to the left are less than negative 3. It's the same process for solving even if I have a fraction. But again, the key idea when solving these is make sure you do not have a negative with your exponent. If you have a negative with your exponent, that's okay, but you'll just have to flip that inequality sign. So here I will not have to flip my inequality. I'll solve this just like any other normal equation. Here I have a 7 minus 2, positive 7, and a minus 2 is a 5. This would be 1/3 x. So 1/3 is a lot like dividing by 3. Let me get rid of that by doing the opposite, by multiplying by 3 on both sides. And I will get x is greater than or equal to 15. And then to graph that, I've got 15. I have an equals to symbol, so I'll have a closed circle because 15 is equal to 15. and I can shade to the right, because this inequality symbol tells me greater than or to the right. Okay, let's take a look at 6 and 7. Same process as solving any other equation. So we can do our parentheses, we can distribute, I'll get 4x plus 6x minus 10 less than or equal to 5x plus 15. And just like any other equation, we can combine some like terms. We can combine our variable terms. We can add that 10 over, and notice that my variable term, 5x, is positive. So because that's positive, I do not need to switch that inequality sign when I divide. And I will get x is less than or equal to 5. And then when I graph that, I'll put a little 5 in the middle. I have an equals to bar underneath that inequality, so I'll have a closed circle. And that inequality says less than, so I'll go to the left. And our last one here, again, we can do the same thing as what we do on any other normal equation. Distribute, half of 12 is 6, half of 18 is 9. And this one's going to be a little bit strange, because if I were to combine my like terms, I'm going to get negative 9 is less than negative 3. Well, hold up. This is true, but there's no variables. So whenever I end up with no variable terms, I have to ask myself, is that true or is that false? If it's true, I'm going to get infinitely many solutions. And if it were false, I would get no solution. So for example, let's take a look at a couple more here. I'm going to ask you to try 1 and 2 on your own. Pause the video, try them, and then unpause and check your work. All right, here I would end up with 3y plus 18 is greater than 3y plus 18. And if I were to simplify this, I would get 18 is greater than 18, which I know is false. 18 is not greater than 18. It is equal to 18. So that's false. In that case, you would have no solution. And on 2, what you get is negative 18 is greater than or equal to negative 18. And what makes the difference here is that equal to symbol. That makes a world of difference, because negative 18 is equal to negative 18. So this is true, which means, like before, I will have infinitely many solutions. All right, I'm going to ask you to try 3 and 4. These will have one answer, one solution for both. So I'm going to ask you to try those, pause the video, check them out, unpause, and get the answers. All right, 3. We should have y is less than 0, so put a 0. And that would be an open circle, and I can shade to the left. This would be x is less than 10. We put a 10, open circle, shade to the left. Now, a couple things to think about. Why did this inequality switch? It's because I had a negative with the variable. Because I had a negative with the variable, I have to switch that from a greater than to a less than.